security at scale. So we all know that, how businesses are scaling and how businesses are operating at scale in order to leverage or in order to drive, digital transformation in their organizations. So that's what how security and privacy plays out at such a large scale is what this whole conference has been architected around. So this particular workshop is being hosted jointly by DSA and Akamai. And in order to do the honors, I would like to request Mr. Ashish Ramesh, security architect from Akamai, to join us please on the stage. And Mr. Vivek from DSA would be facilitating the workshop. So Ashish, if we could have you please on the stage. Yeah.
So what we're going to talk today is about the Akamai platform. We're going to talk a little bit agnostic of Akamai as well. We're going to step outside the box and talk about security from our perspective. What do we see across the internet as of today? How do we see that web applications which drive businesses on the internet today need to be protected? And we're also going to talk about protecting the enterprise itself, right? That's within your own network. Now, just to give you a glimpse of what the platform is all about, the Akamai platform is all about, and how we started off, right? So Akamai started off in the late 90s when Dr. Tim Berners-Lee, who's the father of the World Wide Web, came to our CEO and said, hey, I have sort of come up with the World Wide Web concept, and I can foresee that in a decade or 2 decades from now, it's going to be a very crowded place. So how do we come up with some kind of an algorithm and an infrastructure setup to sort of support the scale, right? And that was the genesis of Akamai as a company. So what our founder, Dr. Tom Layton and Danny Lewin did is they started setting up servers across the globe, and they said, hey, you know what? We want to be as close to end users as possible and deliver content to them locally instead of going back to the data center every single time you have to fetch for content, right? So they set up an initial setup. This was in 1999, and as of today, we have about 250,000 servers deployed across the globe in over 1,600 networks in about 130 plus countries, right? So when I say we've deployed servers across 1,600 networks, what I mean is we've gone to ISPs and said, hey, we're going to deploy Akamai servers, what we call edge servers, and I'm going to refer to edge as a terminology throughout my presentation. We're going to deploy servers within your network, and then any end user of yours who's actually making a request to applications which happen to be our customers' applications, our servers which are deployed in your network will sort of serve content to them or will play as a reverse proxy to those end users, right? So as of today, we have partnerships with about 1,600 networks, and we've deployed about 2.5 lakh servers across the globe. So any point in time you've used the internet to access any business application, it could be you're watching a cricket match, you could be listening to music, you could be watching the Olympics, you could be browsing your social media networks, you could be doing banking, or internet banking, any BFSI application you're touching, in all probability you would be using Akamai, right? So Akamai started off with as a media delivery house where we used to deliver media content. Then we were caching stuff and serving cached content for retail customers of ours and other large customers across the globe. Then we got into accelerating dynamic content, right? Any transactional applications which has dynamic content, we got into accelerating that. And then by the end, in the 2000s, we realized that Akamai delivers about 30% of the world's internet traffic. Now, if you remove a good chunk of the unwanted stuff on the internet, Akamai delivers a large portion of the internet traffic. Our platform today, we see about 82 terabits per second of data flowing. through the platform on a daily basis. That's the peak traffic what we've seen across the internet, and we deliver all of that using this platform, right? Specifically, specifically in India, we see about 1.6 terabits of traffic flowing through the platform. We have about 4,500 servers. We have 168 points of presence in about 44 cities. So what all this means is basically we are very close to all the end users out there. So 95% of the world's end users are one hop away from an Akamai Edge server, right? This is an overarching slide as to what we're going to discuss about today. On the left, what you'll see is we're going to talk about DDoS protection. We're going to talk about application protection with our web application firewall. We're going to talk about reputation services, basically how we give reputation to IP addresses making requests to customer applications. We're going to talk about API governance and API security in itself. 3-4 years ago, we used to see about 23% of all traffic on the Akamai platform was APIs. As of today, that number has gone up to more than about 70%, because APIs are being used across mobile apps, desktop web, mobile web. So we're going to touch upon API specifically. We're going to talk about DNS for a bit. Generally, in my experience across working with customers across India, a lot of people don't pay as much heed to DNS security and protection, even though it's a single point of failure, right? Everything else fails if the DNS fails. So we're going to touch upon that. In the center, what you see is a paradigm shift what we saw about 4 years ago with bots sort of creating havoc on the internet, right? And it all started off after the Mirai botnet attack, which happened in Japan, which brought down the Dyn network. That was the genesis of bots, and how any device or any IoT device or any device which had internet connectivity, which had an IP address, could be used as a potential node to attack anybody, right? So we're going to touch upon that and what are the different kinds of bot attacks what we see. We're going to talk about identity management. Akamai has stepped into the identity management space, but we're going to concentrate a bit on that. And then we're going to talk about zero trust. And when we talk about zero trust, we're going to talk about protecting your own enterprise. How do you sort of expose internal applications to end users? It could be your employees, it could be your vendors, it could be anybody, right? It's no longer, the perimeter has gone beyond your network, outside into the public internet, and people need to access applications for you to render those services to you. So how do we protect those internal applications? And then how do you protect your internal network against malware and ransomware kind of attacks, right? So the two on the left is basically all traffic flowing from outside on the public internet back to your data center. So this would cover all web-facing applications which are exposed to the public internet where you're running business on. The zero trust model is going to specifically concentrate on internal applications which is used for internal use and purpose. And if you want to expose them to your employees or vendors and stuff like that, it's going to concentrate on the inside-out traffic, if I may, right? So very quickly, Kona Site Defender is our name for our web application firewall and our DDoS protection. And we're going to talk about the DNS services, right? So when we talk about having an application up and running on the internet, we talk about something called a fire triangle. So we need your infrastructure up and running. That's what we're going to discuss in parameter 1, right? So parameter 1, which is the infrastructure part of it, which needs to be up and running for any web application to run on the internet, right? So, and a common way of attacking the infrastructure is through DDoS attacks. Now, everybody is aware of the traditional DDoS attacks, where there's large volumes of requests coming back to your data center, overwhelming your compute resources, and then bringing them down, right? Now, what I'm going to go through the slide is the couple of different types of DDoS attacks, what we see today, which are more sophisticated than what the industry saw about a decade ago, right? So the large DDoS attacks is still prevalent. We see a lot of them targeted at our customers, and Akamai has the largest infrastructure in terms of capacity to sort of fend off any attack against any of our customers, right, who are there on the platform. The largest attack, what we saw was a 1.3 Tbps attack at GitHub. And then, our SOC team was proactively monitoring it and stopping it. Now, these are straightforward DDoS attacks for us to stop. The second kind of DDoS attacks are application level DDoS attacks. The one which I was speaking about are network layer DDoS attacks, like TCP SYN floods, TCP, reset. These are targeted at the network layer. Your identification parameters are IP addresses. The Akamai platform by default, just by you routing any application traffic through the platform, gives you 100% protection against network layer DDoS protection, right? You don't have to, we don't charge any of our customers for that service. It comes for free. We are protecting our own network, and by virtue of us protecting our own network, if you just deliver the applications on our network, you automatically get network layer DDoS protection. Now, the second part of it, which is the application layer DDoS protection. These are HTTP GET floods, HTTP POST floods, right? Origin error responses. I send a request saying www.customer.com/ashish.jpg. Does not exist. I send that 1 million times. That's 1 million 404s being computed by your data center, right? So it is going to bring it down. Now, these application layer DDoS protection is covered by our WAF. There are multiple levels of check. We check across a 5-second window. We check across a 120-second window. And then we put blocks on that IP address for 10 minutes. Why do we put it for 10 minutes and why don't we block that IP forever? It could be a compromised node, which is your machine, my machine. You have a plugin on your browser. That plugin is, driving some malicious activity. So if I block you forever, then you might be a genuine user. You might not even know that there's malicious activity going on in a node. Hence, we sort of pick that IP address and then go back and then put it in a deny forever, if you want to put it in deny forever, right? The third kind of DDoS attacks is DDoS attacks at the API layer. APIs are exposed on the public forum so that people can actually call those APIs to get different kind of services. The two which I spoke about, the network layer DDoS attacks and the application layer DDoS attacks, a similar kind of DDoS attacks are targeted at the APIs as well. And the fourth one, and the sophisticated ones, are the ones which are launched using an application code. If you can just write a script, a small script, which is an infinite loop, and just send it back to your web server, your web server starts computing that. And as soon as it starts computing that, then it's going to consume RAM, right? And then it's basically going to crash. All that you can do is switch it off, switch it on. It's the cheapest kind of DDoS attack to launch. I wouldn't call it DDoS, I would call it DOS, because it's denial of service for that web server at that point in time. You send a 8 KB, 10 KB JSON request, just goes and sits on that web server. The web server, as soon as it processes that request, it's going to die down, right? It's going to consume all its RAM, it's going to die down. It's easy to launch. The other ones which I spoke about, the former types of attacks which I spoke about, needs resources. Somebody needs to pay for a service, right? To get the botnets, to get the tools, to get the infrastructure to launch those kind of attacks, right? So perimeter 1 is extremely important to protect, and Akamai's Kona Site Defender's WAF protects you against all those DOS attacks, and that platform itself gives you network layer DDoS protection at no cost at all. The web application firewall, right? Now, these are application layer attacks. These would be your risk groups like SQL injection, cross-site scripting, command injection, right? They're common. It's everybody has heard that name. And in spite of that, when we turn on our solutions, when we're doing trials for our customers or whoever it is, we see tons and tons and tons of gaps in the application build out. And that's just because of the urgency in which the developers are asked to deliver applications, right? This functionality beats security. So we want this functionality, the developer just churns out that functionality very quickly, but then there are lots of gaps in the application, right? So the most number of attacks, what we see across the globe today, are still SQL injection attacks. Everybody thinks SQL injection is done and dusted, but it's not, right? So our web application firewall is one of the most granular application firewalls. So how did we come up with it? We started off with a mod security rule set, and because Akamai sees so much of the internet traffic, and most of our customers are the top businesses in their own verticals, they're the most attacked as well, right? So we get to see their attacks, and vis-a-vis which we just feed that data into big data systems, and we've come up with something called cloud security intelligence. I'm going to use that term throughout the presentation, and that cloud security intelligence engine is what runs all our security solutions, or sort of fuels the intelligence into all our solutions, right? So we build something called a cloud security intelligence by churning all that internet data, what we see, the traffic data, what we see, and the attacks, what we see 2 billion triggers every day. Security rule triggers. And because of those triggers, we've come up with a very granular rule set. And the rule set has something called anomaly scoring. I want to take a minute to talk about anomaly scoring because it's important in the way that it is not binary, right? A lot of WAFs, a lot of security solutions are very binary. It says, hey, there's a rule triggered, so I'm going to deny you. There's no rule triggered, I'm going to allow you, right? That means I'm going to bombard my customers with notifications, messages throughout the day, throughout the night. We don't want to do that. We want to inform them, or we want to notify them if it is true and if we know it's true, right? So what we've done is we've come up with a scoring mechanism. So if there is, let's say, a risk group called SQL injection, and there are 100 rules under it, then we've given each rule a score, right? Like 2 or 3 or 4. And it's an engineered score, right? Now, a cumulative of the score of multiple rules triggering should exceed the threshold of the risk group itself, right? For example, let's say a SQL injection is 20. Cumulative score of the 5 rules should exceed 20, and only then will I say this is a SQL injection attack, right? It gives us the accuracy so that when we say something is an attack, it really is an attack, and I'm not sending you a false alarm, right? It separates us from how people are doing WAFs out there in the market, and it's worked out really well for us. It makes our rule set extremely accurate, right? That's the second parameter of the fire triangle, right? That's the application should be up. The first one was infrastructure should be up. Second one is application should be up. Now the third one, and the most important one, actually the smallest one, right? Nobody pays heed to this because the service itself costs very less. They spend tons and tons of money in putting up your DDoS protection, your WAF and everything. Everybody forgets about the DNS. And I can't tell you how many number of times I've got a call at night saying, hey, we can't be accessed, and they're checking everything. And then you find out it's just that your DNS service is not available, because most of the people, what they do, when you register your DNS on your BigRock or GoDaddy or whatever, you get those free name servers. Everybody just puts the zone files there and then they forget about it. And I think life's very simple. It's just that when those name servers get attacked and when they are down, then your entire data center, which you would have spent millions of dollars or crores of rupees setting up, just does not work, because there's no way for that end user to know where you are located, right? So please pay heed to your DNS setup. You need a DNS with 100% uptime SLA. A lot of people speak about performance with DNS, etc. While the performance is important, it's still in milliseconds, right? A DNS resolution is 120 milliseconds, 100 milliseconds that we understand for retail customers extremely important to shave off those 10, 20 milliseconds. But 100% uptime SLA is absolutely important and needs to be any cost, right? So this is the third parameter. So in a fire triangle, when you take care of your infrastructure, when you take care of your application, and when you take care of your DNS, then you sort it. Then you have your application which is driving that business up and running on the public internet, right? Okay, sorry. So that, in a sense, is how we look at protecting applications from DDoS attacks, from application layer attacks, and from DNS attacks, right? Now, another thing what we provisioned is the internet is large and there are tons and tons of servers across the globe. We want to give a trusted set of servers to our customers and tell them, hey, you know when you get requests, you're going to get it from these set of servers, from these set of IP addresses. We own them. Akamai is your partner. So any request which is going to come to you is going to flow through these servers. And because it's going to flow through those servers and those IP addresses, and we've given those IP addresses to you beforehand, you know it's coming from a trusted source. And because you know it's coming from a trusted source, and all our security solutions are there in front, on the edge there, so you know it's cleaned up traffic coming through those trusted IP addresses. So if I have to sum it up, the way we've architected our security is instead of setting up security controls at your data center on a couple of appliances or one appliance and creating a bottleneck, we've pushed our security policies to the edge of the internet. We want to protect attacks where they originate. If an attack is originating in Australia, I want to stop that attack in Australia instead of getting them back to your data center in Bangalore or Bombay or Delhi. If the attack is originating in the US, we want to stop it there. If an attack is originating in Europe, we want to stop it there. Now, so basically security policies are pushed to the edge of the internet. So you can think of our WAF and our DDoS protection and whatever I spoke of till now sitting on those 250,000 edge servers. So you can think of 250,000 WAFs front-ending, right? And then wherever the attacks are originating, we stop them there. It's closer to an end user, so we deliver locally, and it's closer to an attacker, so we stop locally. And underlying all of this, which I'm not covering too specifically in this agenda, is our performance solutions. So Akamai delivers performance solutions. We do it with caching, we do it with network level optimizations, we do it with application level optimizations, we do it with image management, video management, anything which your application uses to load faster, we optimize those resources, and we're doing it at the same edge servers where the WAF is present. So basically, there is some kind of delay which a security solution brings about. It brings about greater delay if it's sort of here. The delay which we bring about could be a little minor because you're still looking into traffic coming in. The performance solutions are implemented so that the delta between the performance solution and the security solution is always positive, right? So if your application, just put that in numbers, hypothetical numbers, if your application, let's say a page loads in 10 seconds, and if my performance solution can make it load in 6 seconds, and my security solution adds a half a second of delay, I am still better than what you were before. That's what we aim to do, right? So it comes bundled, our performance solutions, with our security solutions, just to ensure your application performance is as good or better than before, even once you come on board the security bandwagon. Right, so we were on this trusted set of IP addresses coming back. And we also set this up so that nobody bypasses the Akamai platform and comes to your origin directly. A lot of people think changing an IP address will, will solve the problem. It doesn't solve the problem. All your IP addresses are stored in a lot of archived sites. Like 10 years ago, you can find your IP addresses, right? So what they do is they try to sort of bypass this platform and then they come to you directly. This is a way for us to enforce every end user and attacker to come through our platform. So what do? You take those IP addresses from us, you'll put it on your firewall, and you say, hey, only if the requests are coming from these trusted IP addresses, I'll allow them. If it's not, then I'm going to deny them. Anybody making a request directly to your data center, you deny them. In that way, you look at traffic when they come from these IP addresses that they're cleaned up, everything is nice, and then you can serve out that traffic, right? APIs. Very quickly on APIs. APIs is the center of everything as of today, right? It's difficult to sort of manage them, but it's very easy, and the services that you can render through these APIs are brilliant, right? So it's the center of every digital experience, and this is what I was talking about before. So it was about 26% in 2016, and as of 2018, it's 69%. That's the amount of traffic we see across those verticals with API traffic. And this was a gaping hole in the security landscape or the architecture of everybody in the past 3 to 4 years. They never expected the consumption of APIs to increase like this. They said, hey, I'm protecting my desktop web site. I'm protecting my mobile website. That's if you have an M.dot site or you have a PWA or whatever it is, right? But then nobody bothered too much about APIs, right? And most of the attacks behind the scenes were happening on APIs. So what Akamai went and did is we came out with an API protection, and then it's important to understand, right? It's not easy to manage. Like people like Google, people like Facebook have had data breaches, right? This literally the pinnacle of the software development world across the globe. It just goes to show how difficult it is to manage APIs, and it's difficult because all these APIs are managed by small teams for different functionalities of those APIs, could be microservices, and everybody is worried and bothered about fine-tuning their API functionality, fine-tuning their setup, right? There is no communication between these teams who manage different kind of APIs, right? And because of this development cycle, we see a big gap in the security setup of those APIs, right? And it's not as simple. Everybody says, "Oh, API is simple. It's HTTP at the end of the day, right?" But the protocol itself is a little more complex, and only a negative security model will not help you protect attacks against the API infrastructure. You need a positive security model, right? So basically what we've done is we've put it into 3 buckets, right? We say, hey, we want a negative security model. That's the same negative security model which we spoke of with our rules and stuff to look through the API. We need parsers to first parse those API requests, understand those API requests, and then apply those negative security rules. But then we also need a positive security rule, right? Because not all attacks can be stopped with a negative security rule set. I mean, what I mean by when I say positive security rule set, it's basically me defining an API endpoint on Akamai, right? At our edge servers, we say, hey, this is the definition of that API. Let's say it's a login API. I'll say, this is a login API. It can be reached at www.customer.com/API/login. The only HTTP method it allows is a post request. It does not need to allow a GET request. It does not need to allow any other HTTP method. It needs to allow only a HTTP post because that is what it's there to do. It's supposed to give you login. And then you can say, hey, this is the string length, right, of the username. This is the string length of the password. And let's say you have an API nested loop. You say, this is the length of it, right? So you very granularly define an API. So when a request comes in, you check if that request is in line with that API definition. Only if it's in line with that API definition, you allow it inside. Once you allow it inside, you parse that API, you put it through the negative security model, and then you check it against the rules, and only then will you let it proceed back to the data center. So there's this additional step of security with API protection in form of a positive security model in front of a negative security model, which is extremely important, right? And we already spoke about protection from DDoS attacks for API specifically. Because it's publicly exposed and because anybody can access those APIs, it's all the more vulnerable to attacks, basically denial of service attacks, again, targeted infrastructure. So these are the 3 aspects which we look at when we want to protect APIs. To just sum it up, and I'll take a pause after this, the architecture which we have adopted is to have security policies as far away from your data center as possible, closer to end users, closer to attackers, right? So that your attack traffic is mitigated where they originate, and we don't get them back towards your data center to sort of clean them up. So we get only clean traffic back to your data center. We want to stop all network layer DDoS attacks as a part of the platform, and we want to protect all. Another point which I forgot to mention, we work on the Akamai platform which I described here. We work on port 80 and 443, so it's for HTTP and HTTPS applications only. We have a completely separate network. If you want data center protection against all ports and protocols, we call that network prolexic. We have about 16 to 17. We have about 17 scrubbing centers across the globe with about 8+ terabits per second of attack traffic protection. This platform, what we're speaking about, is the Akamai platform, which is dedicated to media delivery, which is dedicated to performance, which is dedicated to the security services, which I spoke of, supports HTTP and HTTPS applications only. And most of our customers who do business online, about 80% of their applications are running on HTTP, HTTPS. So once they onboard their applications on this platform, we do not allow traffic which is making requests to other ports, other protocols, etc., to even come through the platform. We just drop those requests. So you're protecting only those HTTP, HTTPS applications, right, against all kinds of attacks. You can do geo-based blacklisting. You can do IP-based blacklisting and whitelisting. Akamai also gives you, a pre-populated IP list, like for example, Tor exit nodes. We know those Tor exit nodes are bad. We give you those pre-populated lists so that you can just put it there and say, hey, deny, from the word go, right? We spoke about the DDoS protection. This is the rate controls. This is application layer DDoS protection for incoming GET requests, POST requests, origin error responses, etc. The WAF we spoke about, which is our rule set, which has come out of our CSI engine, which is basically by looking at those triggers, the billions of triggers, what we see, and we come up with either new rules, new functionalities, or new products itself, right? And then caching goes a long way in helping you protect against attacks. The technology, everybody thinks of the caching technology as trivial, but 60 to 70% of most of the applications are static in nature. If I can deliver them locally, think of it as reducing your attack surface by 60 to 70%. Now only 30 to 40% of the traffic is coming back to your data center. So it goes a long way in helping reduce that traffic coming back to your data center, right? So before I get into the bot management piece of it, I just want to take a pause. Any questions in the room? I'd be happy to address them. Yes? Right. Absolutely. Absolutely. So these 250,000 servers are deployed across the globe. Then the security services will come in place and check, right? Ideally, it won't. We're a network-aware platform because we have those peering relationships with all those networks across the globe. We know where it's originating from. That's where our client reputation services come into play. So I didn't touch upon the client reputation service. So very quickly before I come to you, our client reputation service gives reputation to IP addresses from 0 to 10, 0 being the best and 10 being the worst. We have a couple of categories under which we give reputation to IP addresses. And we see an IPv4 address hitting the platform at least once in 15, 20 days. We see an IPv6 address hitting the platform once in a month. Which will be working in a silo. There are multiple feature sets which will be working across multiple solutions which are architected together to give you that security which you need. So yeah, I got the question. So just to reiterate the question, it says 0.6 says use best WAF rules. How is our WAF rule set different from other competitors' WAF rule sets, right? So a WAF, how do you fine tune a WAF rule set, right? Everybody started off with mod security, right? Back in the day, nobody knew anything else. So when a WAF rule set is taken, you need intelligence to be fed into the rule set to sort of enhance the rule set. And they need to be, then there's a people interference. It's not machine learning. There is machine learning at the back end to understand the attacks. But to devise rules, you need people. So we have hundreds of people in our threat intelligence team who day in, day out, look at the traffic, which is collected by the triggers across the globe, and then they come up with rule sets. You'll be having the? A SIM solution is basically, a SIEM solution is basically used to gather logs and traffic from different appliances or different security controls what you put in place, gather that into one portal or one command and control center, and then view it there. Akamai also has an analytics tool, and I'll explain what the analytics tool is. But just specifically to your point, a SIM solution is basically to view the attacks. Right? It has nothing to do with the trigger itself. Appliance A sends logs, right? In whatever format, syslog, whatever that format is. Appliance B sends it, appliance C sends it, appliance D sends it. It basically stacks up everything and gives you one single view to say what's happening across my application landscape. Right? That is what a SIM gives you. Right? The WAF is fine-tuned and very granular and crisp because of the data what we see on the platform. And again, it's that cloud security intelligence database what we have as to, and you'll see more of it as I go into the bot management piece of it, as to how granular that database is, right? And it's because Akamai sees so much of that traffic on the public internet. We understand that data, we have intelligence around it, and hence we're able to build more granular WAF rules. One last question, and I'll just move on in the interest of time. And I'll connect with you guys offline. I'm here. Yeah. It depends. It depends what you're using your MPLS network for. Does compliance drive your MPLS network adoption? Does something else drive your MPLS network adoption? If you've just put in an MPLS network for security, for web applications, of course you can do away with it. If compliance drives you to use it, then you can't do away with it, right? So, yeah. You had a question.
WAF controls do not have these 4 different dimensions or 4 parameters of the WAF?
Very good question. Thanks for asking, because I literally skipped that part completely. So we are a solution who are an origin agnostic solution, in the sense we really don't care where your applications are deployed. Some customers have deployed it at a private data center as of today, and some of them have moved completely to the cloud. Some of them have a hybrid architecture. They have some applications in the private data center, some applications in the cloud like AWS or Azure, some in a colo, wherever it is, right? So we don't want our customers to deploy the same solution at multiple data centers. We don't want to say, hey, I'm in the private data center now, I'm going to put X number of security controls here and spend X amount of rupees here. Then I'm going to go to the cloud, I'm going to put X number of security controls here. Then I'm going to another cloud, I'll put the same setup, I'll replicate it here. It's CapEx investment, right? We want to sit in front of all your data centers as a reverse proxy on the public internet, and then say, I will clean up everything, and then I will send back traffic to whichever data center you've defined me to send my traffic back to, using my traffic manager solution. So I can say, hey, this is application 1, send it to data center A. This is application 2, send it to data center B, C, D. It could be on-premise, it could be cloud, it could be anywhere. Doesn't matter. So you deploy one solution. So you're doing cost savings there, and it's optimizing on the platform. To your second question, what is the difference between a cloud service provider's WAF and Akamai's security solution? A cloud service provider is in the business of providing you storage, compute, right, to deploy your applications. He is not in the business of providing you security. Hence, the cloud service providers advertise saying, hey, buy Imperva's WAF, or buy F5's WAF, or buy some other OEM's WAF. They're not saying, hey, buy my WAF. They're saying, I'll give you a VPC in which you can configure your security controls. They're not saying, you are good with my VPC. I am saying you are good with my security solutions. And generally, it so happens it's a DIY, right? Most of the cloud providers are a DIY because their main business is compute. They are not in the business of giving you security, right? So they say, hey, this is an F5 solution. These are the F5 rules. Take it. But then you need people to implement it, right? You need to monitor it. You need to manage it. That part of it, like I tell a lot of people, you might have literally the best solution in town, but if it's not configured, it's as good as junk, right? It's useless, right? So from that perspective, because we're a managed security service provider, the solution, one of my colleagues always says this to people whom he meets. That it's not solution-driven expertise. It's expertise-driven solutions, right? You need expertise to drive the solutions. It's not that you deploy the solution and it's going to work on its own. That piece of it is important. Even from a capability standpoint, we concentrate on security day in, day out. This is our bread and butter, right? It's a security. Akamai is a security-first company as of today. Right? And all the services which come along with it make our customers' life simpler. Like just within our SOC, we have 6 SOCs across the globe, 24/7, 365, follow the sun model, multilingual, right? They do proactive monitoring. There are multiple teams within the SOC. There's people to observe traffic proactively. There are people who communicate with customers. There are people who actually put in controls, and then there is somebody who's orchestrating all of this, right? We want to come and say, hey, customer, you know what? You're under an attack. We put these controls in place. It's a production setup, so I'm asking you for approval. Can I go and just deploy this? And we want you to say yes. Instead of, and most of the times attacks are used, like for example, the DDoS attack is used as a smoke screen to launch an application attack and steal something from your database. Or both of these are used in tandem to launch a credential abuse attack and get past your login endpoint. While you're trying to battle this, they're trying to get through another door. We don't want you battling. We want to feed you with information. We want to feed you with intelligence, and we want to feed you with controls, which we've already deployed, and we would just want you to say yes. That's our approach to security, which is missing in the cloud providers.
There are mergers and acquisitions, right? So where some companies are coming out of the parent organization, they want to set up everything on cloud. There's nothing called on-prem data center.
Yeah.
So in those kind of scenario, how do I put this?
Then if we go back, all applications in the cloud are protected by Akamai. We have tons and tons of customers who have started off their companies on AWS or Azure or Google Cloud, and they're still on those cloud service providers. It's like when I look at the cloud from my perspective, or like an AWS or Azure, it's just another data center. It's just that it's not yours. It's just that it's shared. Otherwise, it's just in a physical location. It's another data center. It's a shared data center. A private data center is owned by you. That is not owned by you. That's the only difference. So for us, we go back to a data center, right? It doesn't matter whether it's a cloud or an on-premise setup, whether it's yours or somebody else's. You can define go here and we go there. I'll just cut. Yeah, sorry.
Hey, one last question. So this is predominantly de-risking a centralized system and then taking it to a distributed way where we can ensure that the risks are mitigated at the perimeter or the closest edge. So how about the futuristic peer-to-peer networks or distributed IPFS kind of systems where the information itself is distributed?
We will talk of this offline. I don't want to dive into that because it's a long discussion. It's completely different. We work. It's just to answer very briefly as of now. We are working on it. We are there in a lot of. We're working on a P2P network specifically with your media delivery services, etc. With set-top boxes having IP addresses, etc. IPTVs coming up. We want to store content locally there, serve it off there. So we are working on the technology. We are aware. We are heavily invested in blockchain as a technology. We are heavily invested in your P2P technology. We will discuss this offline.
Thank you.
Right? And IoT as well. Moving on, right? Time check. So the traditional WAF and the traditional DDoS and everything was working well till about half a decade ago, when all of a sudden we saw tons and tons of automated programs making requests. We had customers, I'm sure there were a lot of other customers reaching out to other OEMs saying, hey, I am getting millions and millions of requests. Your rate controls are not catching them. Why? Right? Because there were 1 million IP addresses sending one request. Why would you stop, think of a WAF, or think of a rate control, any OEM, anybody, Akamai included. How can I say an IP is bad, other than the reputation service? How can I say this request was bad, or this requester has bad intention if he sends 2 requests a day? Nothing. I will just go through the WAFs. It'll go through your firewalls, any firewall, any WAF in the world, right? That was the genesis of Bot Manager, right? We figured that there's so many automated programs. You can spin up an instance on AWS or wherever it is, on digital oceans of the world, costs you nothing, put up a script, and just scrape a customer's website. You have an aggregator website as a business. I scrape your website. I can set up aggregator1.com, right? You have an e-commerce website. I can scrape your website. You have a banking website. I can do a lot of malicious activity. They get past your login endpoints, right? And I'm going to talk about that. So, and there's nothing bad in what they're asking. Like in a WAF, you've got to understand the difference between a WAF and automated programs, right? A WAF has something malicious in it. It has a malicious code or a script or a JavaScript or something which is being injected, which is bad in nature. Rules are deployed in the WAF to say, hey, this is bad, I'm catching it, right? With respect to automated programs, there's nothing bad. It's just that humans are not making those requests. That's the only difference, right? So it becomes a little more complicated because there's no simple way to understand what is automated, what is not automated, who are humans, who are not humans, what are they requesting it for, etc. But most of the people think of bots as a security problem. They think it's bad, I'm going to either allow it or deny it, right? It's like a whack-a-mole situation. You whack it, you stop it, they're going to just tear down that instance on AWS, put the same script on DigitalOcean, and make the same request to you again. Again, they have like somebody scraping a e-commerce website is not launching an attack at you. He's just getting information which benefits him from a business standpoint, right? Now, most of the automated programs are there for some financial gain. Nobody has the time or money to invest in paying for tools, paying for automated botnets and services to launch bot attacks at you. Nobody has the time. They do it only because there's a financial incentive, right? And the financial incentive could be they scrape your information, they have business intelligence, they undersell you then. They could get past your login endpoints. They could submit fake leads to you, right? And dump your database with enormous amount of fake leads, right? Think of a situation where an automated program fills in unwanted leads into your system. You have 1 lakh leads every day which is coming in. You have a call center. Those people pick up the phone. Those people call those people. They're ghosts. They don't exist. But you're still paying them salaries. You're still paying for the building cost. You're still paying electricity. You're still paying phone bills. And there's nothing coming out of those leads. And you're probably even paying a digital marketing company to get you those leads. So there's massive business loss at the end of it, right? Such use cases is what Bot Manager is designed to handle. And also, what we've seen across the region in the past year and a half, 2 years, is a lot of people are using multiple IP addresses to launch denial of service attacks. Very few requests, lots and lots of IP addresses. So we just go through this. So are you aware, just in the interest of, okay, just in the interest of time, I'm sure everybody is aware of the problem itself, right? The bot problem itself. There is performance degradation because of automated programs. You scrape information of competition. There's, a web experience. There's a sales revenue impact. If your competition is taking off your leads, etc. Your marketing teams have problems with skewed analytics, etc. And there's a security problem as well, right? Now, I just want to show you how easy it is to sort of, launch attacks, right? Everybody thinks you need to really be a sophisticated attacker to launch attacks. That's not the case, right? You can download a tool. You get it literally at $0, $29. It's cheap. There are tools in India with our retailers, our banks, our BFSI customers, login, endpoint, API is already configured in those tools. All that you have to do is upload an Excel sheet with username, passwords, and say go. And then it's going to try sequentially of all the username, passwords, and say how many went through, how many didn't go through. And we are human. Most of us use the same username, passwords across the board. And we're going to talk about that. So what I wanted to show in this slide is basically it's not difficult to launch an attack. It's very easy to launch an attack. There are tools, right? Just download that tool. Just type in the host name, type in whatever you want to do, and just click go. And it does everything for you, right? So how do we go about managing bots, right? So there are 4 parts to it. The first part of it is detection. You need to be able to detect before you categorize the bot. So detection is key. And I'm going to talk quickly about detection in the next 10 minutes. Categorization. Categorization is, it's not plain vanilla binary, right? So when we say categorize, we say, hey, there's a bucket of bots which are known to the customer. These are scripts which you would have written, performance bots to monitor the performance of your application, site uptime scripts, right? These are all known to you. Or it could be some vendor using a script to render some services to you. This is what we call customer categorized bots. In the sense, these are automated scripts which you guys know of. We want to put them under a category called customer categorized bots and manage them, allow them. You can get into various granularities as to how do you manage them. You can say, I want to allow this vendor to access my services from 8 p.m. at night to 8 a.m. in the morning. That's timestamp based. Or you say, when this specific vendor comes, send him to data center B. Or throttle my traffic 80% to data center A and 20% to database B. So a very granular way of managing those requests from your customer known owned bots itself. When I say bots, basically scripts or tools. The second category is what we call Akamai known bots. And why Akamai known bots, and why didn't we come up with a signature set similar to, let's say, like our WAF? I write a script today, which is bad, or which is there to scrape. That's a signature today. One of you write a script tomorrow, that's a new signature tomorrow. I can't keep coming up with negative security model signature sets to block automated programs. So what I did is we said, hey, you know what, let's go the other way around. Let's identify all the good guys out there. Whatever does not fall under the bucket of good guys are automatically suspicious in nature, and let's then find out who these suspicious guys are. So we put together a signature set of 1,650 bots out there of companies who advertise themselves as bots and who actually don't do any harm to any of our customers on the platform. So we know they're good, but you can still take those granular decisions, even there, right? You say, your Google, I want to allow you. Your Baidu, I don't want to allow you. Or your Baidu, I'll send you to a static data center setup, or I'll give you alternate content, whatever it is. I will delay your response. I will slow down your response, etc. Right? That is what you see in terms of responses below. It's just not allow or deny. You can slow down your response, delay your response. You can serve alternate response. You can target requests. Then you can monitor and deny. Right? So we spoke about coming back. We spoke about Akamai known bots. This is signatures of bots which are known to us, which are good, which don't do any harm to you. You can blindly allow them, but if you still want to take a granular decision around them, you can. Whatever does not fall under the customer category and the Akamai category of bots automatically falls into a category of bots which is suspicious in nature. And now we want to find out who these guys are, right? And that is categorization, and then what is listed down is the management, and then we'll provide you visibility around that suspicious bots. And for the rest of the bot management slides, I'm going to talk about how do we look into these suspicious bots and what do we do with them, right? So generally, we started off with IP, blocking, right? Back in the day, it was IP blocking. Then there were multiple IPs. We said rate limiting. Then we said, you know what? Let's do anomaly detection, right? HTTP requests are supposed to have specific header orders. They're supposed to have a specific structure. If they're coming from a specific browser version, they're supposed to have a header order structure in a specific way, right? So is it in line? It's not in line, then automatically trigger saying this is not a normal request from a normal browser. It worked well in the beginning 4 or 5 years ago, but then those bots got sophisticated. So we said, let's do browser fingerprinting. I'll drop a JavaScript and I'll see if there's a real browser. If somebody's turned off the JavaScript, then I trigger a no script section. And then I'll pop up a page saying, hey, please turn on your JavaScript. Or I can make them chase some image stored somewhere so that, go fetch that image. I'll give them right? So dropping a JavaScript or dropping a cookie or dropping something is what we call active detections. The HTTP anomaly, which I spoke of before, is a passive detection. And just to clarify the difference, a passive detection is something which you can check on the first request itself. A request comes in, you have some detection methodologies, you check if it's in line with the detection methodologies. If it's not, then you detect them there. An active detection is basically I inject a JavaScript or I inject a cookie as a response to the first request. And in the consecutive requests when they come back is when I try and detect if there are good, bad, ugly, right? Reason I do that is because there are sophisticated tools out there which beat the standard, regular detection methodologies. We want to catch them. What are the active detections we have in place? We can inject JavaScripts. We inject cookies. We compute something called a botnet ID, which is very interesting. We basically say, hey, this is a Mac operating system. This is a Mac machine. This is a Mac operating system. This end user is using Safari. Is coming at a specific timestamp. This is the IP address, and there are tons of parameters. We compute something called a botnet ID, right? And then we see if how many requests has that botnet ID made across the platform around the globe. So basically, if there's a botnet ID attacking you, then I'll say, hey, this botnet ID also made 1 billion requests in the last 7 days across the platform. It gives me a telltale way of saying, this is bad in nature, right? Apart from the other rules which would have triggered, right? Because it would have failed cookie detection, it would have failed JavaScript injection. So basically, what attackers do is they just take a cookie, they use that cookie with hundreds of millions of requests and just reuse that cookie. So we have a way to check cookie replay attacks as well. We drop our own session IDs to check the session. We can do workflow validations. You're coming straight in between a workflow. I can throw you back to the first page to say, hey, come back, go back to the first page and start off all over again because this is not normal behavior, right? Those are active detections. Now, we were doing all of this, but there are tools out there in the market which still can mimic browsers really well. A simple Selenium tool can mimic a browser really well as of today. So we came up with something called behavior analysis. We said, hey, wait, hold on. While we're trying to solve this entire bot problem by detecting bots, why don't we go the other way around and detect human beings, right? Why detect bots? Why can't I detect human beings? If I can detect human beings, if I can track your mouse movements, right? Neuromuscular interaction of human beings with an application is extremely different from how programs interact with applications, and you can't program to sort of copy human interactions with application. We don't want to know what you're doing, but we just want to know how you're moving your mouse, right? How are you typing your keyboard strokes? We don't want to know what you're typing. We want to know the time interval between those keyboard strokes. If we put SDKs in phones, we say, how are you touching your screen? How are you holding that screen? We see the accelerometer and gyroscope on your phone and say, this is, and we take all that information, we call it telemetry information, and we say, take this telemetry information, come back to the Akamai edge server, the same edge server in which the WAF was there, and say, compare it with the database and check if this is human behavior. If it's human behavior, I will let you hit on a sign-in or a login. If it's human behavior, I'll let you hit on a sign-up, generate OTP, submit of a form, or any sensitive information going back to your database, I will let you hit it. If you're not human, I will block you, right? Now, that's human intelligence technology, which is cutting edge. So just do a double click on what I was explaining, right? How does it normally work? Now we've got into credentials abuse, right? What we were speaking about detecting bots is for your scraping. It's basically any scraping or basically information gathering. Any bots making requests to you, hordes of requests to you to gather information is what we use that other detection methodologies which I spoke about, where we try and detect bots and then block them. What about those sophisticated guys? What do they do, right? And I just reiterate, whatever we spoke of when automated programs are there to basically have a financial gain at the end of it. Nobody is just playing around, right? There is a financial gain, and that's the primary motto behind using bots to attack you. So how does credential stuffing work, right? So let's say a customer accesses multiple sites, right? It's human. I tell myself every single day, I'm not going to reuse a password, but I reuse a password, right? I reuse a password. I have like probably 4 or 5 sets of passwords, and there's some combination going around with it, and I reuse those passwords across multiple applications because it's easy to remember. It's impossible to remember passwords of hundreds of applications, right? That's the primary problem. Now, what happens? One of them gets compromised, right? And that database comes out. It's available in the darknet, right? An attacker goes, buys that, and then attacks all these different websites with the same username password combinations. And then whatever successfully went through is a vetted resource, a vetted source of information of username passwords which have gone through. He has that now. That is more expensive than this corporatized user account stuff, right? Now what you can do is you can either go and then attack those sites back. For example, if you have a compromised username password of banks, you can go attack that site back and then siphon off money, literally. Or it could be as straightforward as that. Or if you don't want to make it so evident, what you can do, you can go to a shop, you can go to eBay, you can buy whatever stuff you want to buy. Then you can say, sell it off to somebody, or sell it off online, sitting in a different country altogether, right? And you can't catch them. There is no trail. This is how the fraud happens, right? You can either stop them from buying at the store, you can stop them from, basically going back into those systems, right? Or you can stop them from, trying out those vetted username passwords, etc. Or you can stop, them right when it is happening, right? When the credential abuse first happened, which is trying out those username passwords right at the beginning. This is a life cycle of how a credential abuse works. A lot of people think easy to solve with CAPTCHA, easy to solve with mobile OTPs, but it's not that simple, right? Mobile OTPs have been broken. We at Akamai feel that mobile numbers itself as an identity is is not great, right? You can read up. Risk IQ is a brilliant site where actually I'd recommend go and read up about using mobile numbers as an identity. We as a region, as a country, have adopted mobile numbers so actively and everybody trusts it, right? So blindly, right? But it can actually cause colossal damage. We don't want to trust mobile numbers of identities, right? We don't want CAPTCHA solutions. There are people, CAPTCHAs can be redirected to people who can literally fill in the CAPTCHA, right? So we don't recommend those approaches. We want to detect who are human beings, and we want to allow access to human beings with technology which is more cutting edge than sending somebody an OTP, right? So this is the behavior analysis which I spoke of, which is basically the touch and everything. But just in the interest of time, I want to jump and touch upon a very important topic. Can I have 15 minutes? 10? Okay. So very quickly, we entered into the identity space. We said, hey, you know what? I've been doing all the security stuff. I've been identifying bots. I've been identifying human beings. What if I can look into the identities of customers, right? Then I'd be in a better position to prevent, fraud eventually. But as of today, I want to secure the privacy of those end user identities, right? There are tons and tons and tons of articles out there as of today. Please read up on how there was a funny article which I read recently where the person is saying insurance companies should really insure people of their identities, right? Because identity theft is the most prevalent in the world today. So we said, if we can protect identities itself, then we're protecting a lot of the other stuff along with it. So if I have view into the identity and if I have view into how they behave in the human behavioral technology, then basically if I put them together, then it's like wonderful. That's what we're aiming to do with the identity piece. But this is a larger piece to this, right? Now, what is an identity? Very quickly. So identities have things. They have devices, mobile phones, desktops, tablets. It could be even kiosks or whatever it is, right? And then they have some traits. Those traits are either self-declared, that they've come and told you, I am so-and-so, my email address is this, my mobile number is this, or it could be traits which are transferred. You've logged in through your Facebook, you've logged in through your Gmail, right? I've got some traits from there. Or it's something which we observe, right? Which IP address are you coming from? Which geography are you coming from? Which network are you coming from? How often are you coming? What time of the day are you coming from, right? So all of them have traits. Now, very quick, a problem statement with the identity in the identity world, right, is there are tons and tons of identities which are digitally connected, right? There are 5 million mobile applications which are being used. 1.2 billion websites are there. There are multiple marketing services and companies out there in multiple verticals, right? And there are thousands of data silos of these identities which are fed into these appliances saying render these services, right? And there are about 4% of annual turnover in penalties for non-compliance, right? There's compliance is becoming more and more important, and India is coming up with one soon. People have data of, identity data stored in different geographies for people who belong to different geographies. So there's no adherence to the compliance as of today. That is extremely important. We're going to touch upon that. And the security of those identities itself is really important. You can see those numbers on the right-hand side. Those are pretty alarming numbers, right? The 7 billion breaches, and I think the number has gone up as of now. It's about 8 billion identities which have been breached since 2013, right? And we want to protect those identities as well, right? So what is SIAM? It's basically, C stands for customers. It's a customer identity and access management solution. Basically, it's a way for your customers to sort of manage their own identities because it's constantly changing. The consents are constantly changing. The preferences are constantly changing. So how do you manage that? And how do you scale it to millions and millions of users? Because the traditional IDAM solution is built for an enterprise, right? There's a trust relationship there, and I take you through that in the next slide. And then how can a user self-manage that profile of theirs, and how is it compliant with the regulations of the land and the region where they're operating in, right? Now, very quickly on the difference between IDAM and SIAM, right? Everybody knows of IDAM solutions. All of you would have used it in your offices, but there's a trust relationship there. Ashish goes and says, hey, Akamai, I want to work for you. Here's a contract. You're an employee. This is my name. This is my wife's name. This is where I stay. This is my phone number. This is my email address, right? This is factual information. I'm providing it to my company. And my company feeds that into a database and defines a policy for me. In a SIAM world, the customer is the owner. He will say, this is my name, this is my email ID, this is my phone number. It might be true, it might not be true. On the left-hand side, it's true. On the right-hand side, it's not true, or maybe true, or we don't know, right? And here, I don't have an opportunity to get off the system. There, I can get off your application or your system if I want to. The customer is the owner, right, of his own identity, and he is declaring that identity to you and saying, hey, this is who I am, this is who my wife is, this is who my children are, this is my age, this is what I like, etc., etc. So you're building trust there. And the left-hand side, it's for a very small audience. The right-hand side, the SIAM one, is for a larger audience, millions of users, right? That is the difference. And I'll be happy to address it offline if anybody has any doubts. So very quickly, we work on a hub and spoke model. So Akamai wants to sit at the center of the identity piece and say, we are touchpoint agnostic, we're device agnostic, we're channel agnostic, right? We work with multiple social connectors to help people log in or register from those social connectors, or it could be from these touchpoints as well, right? And the touchpoint does not need to be focused to your handheld devices or your desktop or your laptop. It could be smart kiosks, right? It could be a touch screen machine which is deployed at a store. It could be anywhere. We need to collect information about end users. We work with open standards. We work with SAML, OpenID Connect. And then we also want to orchestrate the identity to their downstream systems. Tomorrow, somebody comes and says, hey, don't use my email address. I want to send a notification down to that email service provider or that appliance, what you have, saying this person has removed consent from using his email address. So please remove this, right? Don't market to this person. Remove the phone number for this person, right? So talking to those downstream systems from a compliance perspective, talking to the downstream system from a service delivery perspective, multiple actions from one identity source, instead of different teams managing those different services with their silos of data of identities, right? So there are three aspects to identity cloud. One is managing the identities. Second is securing the identities. Third is optimizing the identities, right? And we very quickly talk about managing the identities. Generally, any identity solution comes with a UI and a database. What differentiates us is that business logic, what you see in between. It's a custom business logic. It can be customized to any extent based on a customer requirement and use case. You say, I have 10 different websites. I want seamless integration between those websites. When somebody invokes a functionality on website 1, has to invoke another functionality on website 10, can be done, right? And we're going to talk about, and these are called flows, right? It's flows between your different business applications, right? So that business logic is extremely versatile. It's customizable based on customer requirements, right? Second, there's no limit on the number of attributes you can store in our database. You can have 500 attributes if you want to per end user, right? And you can have various relational database attributes, whatever you define, right? There's no limit to that. You can import, your identities to us, either at one-shot importing or something called a lazy migration, which is basically I say, hey, this end user has come, he's trying to log in. Are you there in the old repository? Oh, you're there. Okay, then I'm going to create an entry for you here, right? So in that way, you weed out the people who don't use your system at all, right? So those are different migration types, right? But from a database perspective, no limits. Flows. Master flow can be defined for 100 applications of yours, or you want to segment applications into different buckets and say, I define different flows for them, you can define them. And when I say flow, it's what application 1 is talking to application 2, to application 3, to application 4, right? Or it could be what an end user goes through as a flow. End user comes, signs up, registers, logs in, then he's provided a consent page. Hey, can I use XYZ parameters of you? He says yes. Then you say, okay, what would you like to see today? Then basically they see something, and then the entire customer journey. That could be a flow, right? A flow can be basically the customer journey or the application journey itself. And you can define those flows. Now, we have two ways of integrating. There's a direct integration where we can do API integration. Like, you know, we have our APIs, you put them in your phones, you put them in your desktops, you put them in your applications, and they just make requests back to the Akamai Identity Cloud and then back to your data center. All the authentication, authorization, and the application itself sits at your data center. The second way, or the easier way, and the less headache for our customers is to do it through a hosted way, where Akamai hosts your login page, Akamai does the authentication, Akamai does the authorization, and then basically we define the flows in both cases, and then we just send them back to your data center for them to interact with those applications, right? And that's the architecture of how those two look. And I'll probably, you know, you can get this off us. We can connect after the session. So the self-registration piece is extremely important because, as I said, there is no system administrator or any office admin sitting and managing your identity like how you have in your office, right? There's somebody who is signed up in his own will-wish, and he's trying to sort of use that you know, application of yours or that business application of yours. He needs to be able to sign in. There needs to be, you know, it needs to have social plugins, like seamless way of getting social logins. We can do, you know, your multi-factor authentication. We can do SSO, federation, whatever stuff you want. So it's basically a self-management of the entire portal is what is important. Second part is security. It is the security, and I want, without getting into in depth of this is the security which we spoke of. We spoke of the security which Akamai offers. Now with the Identity Cloud, Akamai deploys the Kona Site Defender, deploys our WAF, deploys our DDoS protection, deploys API protection. You don't have to pay for it. All your identities are protected which are on Akamai, by Akamai Security Solutions, managed by Akamai SOC, and protected by Akamai. You don't have to provision additional security services to protect your identities, right? And compliance. Compliance management is important. Every land has compliance requirements and regulation requirements. We need to be in line with the compliances of that land, right? We don't want to pay penalties. We don't want to store data of an identities of one country in another country or in a centralized location. Just does not work that way. So compliance is extremely important. The solution itself comes compliance ready. So if you're doing business in a region which has a specific compliance or regulations, we follow that for you. We have regions in databases in those specific countries where we store data in, right? So you don't have to bother about it. Scoped access in 30 seconds. It's nothing but role-based access control. XYZ person has access to, you know, an application. Let's say that I'll give you a simpler example. A customer care executive. You've called a business, your businesses, and your customer care representative picked up the phone and he says, I have this issue with the application, can you please help me navigate through it? And then the customer care executive says, hey, yeah, I can, but you don't want the customer care executive to see the details of that end user, right? So you give them scoped access as to what can they see in the application when they're even troubleshooting for an end user, right? Or it could be the end user itself. So scoped access is extremely important. The third piece of it, which is optimizing, right? Preference management. What do you prefer to see on my application? What do you want to? What are you here to do, right? You driving business, and then of course you need to ask consent from an end user. Can I use this information? Either you're asking the end user, or you're asking the end user because he tried to sign up from a social provider, right? Your Googles, your Facebooks, or whatever it is. It is basically building that data platform by taking consents. You have X number of information about the end user. You want to enrich that information about the end user because when you enrich that information about the end user is when you can market to them better and you can reach out to them better and in a very precise way and not in silos like what we've been doing all this while, right? So progressive profiling is a give and take. It's a trust relationship which you build. Nobody's going to fill out 25 questions on day one when you give them a form saying, hey, fill this information about yourself and give this to me, right? It's slowly saying, hey, customer, do you trust me now? Can you please give me your birth date? I'm going to send you a birthday coupon, right? Hey, customer, do you have kids at home? Do they watch TV? Let's say you're a broadcasting provider. You say, do they watch TV? Because those kids are your customers 10 years down the line. You need to know that identity information today to actually target them tomorrow, right? Otherwise, you're blindsided. So progressive profiling is extremely important, right? And the orchestration bit of it, which I spoke about right in the beginning, right? Now you have all these identities, and you have a single database now, which has identity, the attributes around it, right? You vetted it, you've removed duplicates from it, and then what you want to say is, hey, now I have this information, now I've enriched this information, I know what is the preferences of that customer, I know what consents they've given me, now I'm going to downstream push it to those appliances or those services to sort of help reach out to those end users better in an orchestrated way, right? And customer insights. This is the key aspect of everything, right? How do we run analytics? So we basically run analytics on all this information what we capture to say, this is a customer, he came to your application, he came from a specific country, from a specific IP address, from a specific ASN number in the morning. Now he's coming from somewhere else in the afternoon. That's from a security standpoint. Two, what did he look on my website? What is he looking at? How much time is he spending on this space, right? It's basically what is the time spent of that customer on your application itself. And going into the future, because Akamai wants to go passwordless, is our roadmap in the next 4 to 5 years. Going into the future, we want to get straight into trying to identify fraud, because we understand the human behavior, we understand the security aspects of where they're coming from, and we understand the identities. So if you put the identity piece and the human behavior piece and the security piece, then we can stop fraud is what we believe. And that's what we're working towards, and that's what is the roadmap for us. And with that, I'd just like to end. So thanks, everybody. This was the identity piece which we spoke of. The previous one was the bot management piece which we spoke about. And the one prior to that was the WAF and the DDoS piece which we spoke about. I'm going to stitch this entire thing together after my colleague sort of finishes his piece of it. So whatever I explained to you guys right now is traffic coming from the outside, from the public internet, back to the data center. All web-facing business applications exposed on the public internet, which people like you and me are accessing, general users, right? What my colleague Ashish is going to, his name is Ashish as well, and what he's going to speak about is traffic which is getting generated from within your enterprise and going out of your enterprise, or about protecting your internal applications, right? Thanks, everybody. I hope this was informational. I am happy to connect offline on whatever questions you guys might have. Thank you.